Hey everyone, welcome back to Analyze with Casey, where we break down big topics in healthcare, radiology, and AI. Today, we're diving into one of the biggest questions in radiology. Can machines really read x-rays? Like really? Or are they just playing radiologist dress up? Let's face it, AI is everywhere. It's in our phones, it's in our cars, and now it's quietly creeping into hospital imaging rooms like it finished a stealth mission. But for real, this stuff has the potential to save lives, reduce burnout, and change the way we do healthcare. So let's break it down. Let's demystify it. Artificial intelligence is basically the ability of a machine to mimic human cognitive functions, like recognizing patterns or making decisions. In radiology, AI models are trained on huge data sets of images to learn what normal and abnormal looks like. Think of it like teaching a toddler with flashcards, but the toddler is actually a cloud server with 10 million lungs. Now let's talk about flavors of AI you'll find floating around radiology these days. Because no, not all AI is created equal. It's not like one magic algorithm just woke up one morning and said, I diagnose everything now. That's not how this works. There are three major types of AI we deal with in medical imaging, and each one does something a little different. Kind of like how each tech on your shift has their own superpower. One's great with trauma, one can line up a perfect AP chest every time, and one brings the good snacks. You know who you are. So first is classification. This is the simplest type to understand, and kind of the sassiest. Classification AI looks like an image and says, yep, that's pneumonia. Or, no, that's just a normal chest x-ray. It's the binary one, yes or no. Sick or healthy. Lung thing or not lung thing. It's basically a medical magic 8-ball, except it doesn't shake when you get nervous. These systems are trained with thousands or millions of labeled images. You show it a bunch of x-rays labeled as normal and pneumonia, and over time, the model learns what pneumonia tends to look like. It's like teaching a toddler what a cat is, show them enough cats, and eventually they stop calling every animal dog. That's classification AI. Second up is detection. Detection AI is like classification's more detail-oriented cousin. It doesn't just tell you what is wrong, it tells you where it is. For example, there's a 2.3 centimeter lung nodule in the upper lobe at the 10 o'clock position. Boom, precise, helpful. This type of AI is often used for things like spotting small nodules, fractures, or consolidations that can be easy to miss, especially in high-volume settings. It puts a little bounding, boxes, or highlights around areas of interest. Think of it like a digital tech tapping the screen and saying, hey doc, you might want to double-check this. Sometimes it gets it right. Sometimes it draws a box around a perfectly innocent rib shadow. Just like your coworker who insists every artifact is a pneumothorax. Third up, we have segmentation. Segmentation AI is where things get really fancy. This model doesn't just say there's something here, it draws detailed outlines around structures or pathologies, like coloring inside the lines. If the lines were made of pixels and your crown was a neural network. This type of AI is incredibly useful in radiation therapy, where planning requires precise measurements of organs and tumors. It's also used for analyzing volumes, like how big that pleural effusion is, or how much of the lung is affected by pneumonia. And while it may seem like a lot of overkill for basic studies, in advanced imaging like CT or MRI, segmentation can save a ton of time and provide a level of consistency that even the best human eyes struggle with during a 12-hour shift with 4 cups of coffee and 0 snacks. Each of these AI types plays a different role in the workflow, from flagging suspicious cases to helping radiologists focus on the most urgent reads to supporting long-term treatment planning. And they're retrained using different models, different algorithms, and different types of data. AI doesn't just wake up smart. It takes time, training, and a whole lot of labeled images to get there. Kind of like us, honestly. All right, So we've talked about what AI is, the types it comes in, and what it thinks it can do in radiology. But let's be real. Talk is cheap. AI doesn't become intelligent just by us hyping it up. It needs fuel. It needs data. And not just a few images your coworker snapped during flu season. It needs massive data sets. Now, here's the good news. You don't need to work at a billion-dollar tech company or have a radiologist buddy on speed dial to get your hands on this data. There are public data sets out there, completely free and open for you to explore, tinker with, and even build your own AI models. Yep, you, the person watching this in their pajamas. Let's talk about a few of the most popular ones. First up, we've got the NIH Chest X-ray 14 dataset. This baby is like the Beyoncé of medical AI data sets. Famous, highly cited, and way bigger than it looks at first glance. We're talking over 100,000 frontal chest X-ray images from more than 30,000 unique patients, labeled with 14 disease categories like cardiomegaly, pneumonia, pneumothorax, and more. It's used everywhere, from research papers to commercial AI models, and it's a great way to dip your toes into the data lake without drowning. Next up, we've got the Mimic CXR, which comes from the team at MIT, so you already know it's fancy. This dataset contains over 377,000 chest X-rays and nearly 228,000 reports. That's not a typo. These guys didn't just drop the images. They dropped the entire radiologist report with it. You can use this data to train models that don't just recognize abnormalities, but also generate findings or even write simplified reports. Though, let's be honest, they still won't spell atelectasis right without a little help. Oh, and bonus? It's all de-identified, so no worries about patient privacy. And then we've got the RSNA Pneumonia Detection Challenge dataset. This one comes from the Kaggle competition hosted by the Radiological Society of North America, which means it's not just a dataset. It's a battlefield where data scientists duped it out to build the best pneumonia-detecting AI. It included chest X-rays with bounding box annotations showing exactly where the pneumonia is, like someone went in and said, "Here, look at this part." This is the juicy stuff. That makes it perfect for detection, model training, and even better for learning how to build your own. All right, let's get into how AI actually learns. Because no, it doesn't just upload knowledge like it's in the Matrix. There's no magical chip you insert that suddenly makes your computer a radiologist. Yet. The most common way AI learns in radiology is through something called supervised learning. And here's the easiest way to understand it. Imagine you had to find Waldo in a sea of chest X-rays. Now imagine doing that a billion times, with no snacks, and every time you get it wrong, someone points and says, "Nope, try again." That's supervised learning in a nutshell. Basically, you take tons of images and you label them like, this one has pneumonia, this one's totally normal, and this one has a coin in the esophagus because someone's toddler got curious. You do that over and over and over again, feeding these labeled examples into an algorithm. Over time, the AI starts to pick up patterns. It learns that pneumonia often has certain cloudy opacities, or that a pneumothorax usually has a sharp edge with no lung markings beyond it. The AI doesn't know what it's seeing like a human does. It doesn't go, "Oh yeah, I remember that anatomy class back in 2012. No. It's just crunching numbers. It sees pixels, and it calculates probabilities based on statistical associations. It's basically a fancy pattern recognizer on steroids. It's kind of like teaching a kid what a cat is. You show them 1,000 pictures of cats, and eventually they start pointing and saying, "Cat!" even if it's one that they've never seen before. But if you show them a weird one, like a Sphinx cat with no fur, they might say, "Ew, what's that alien rat?" That's AI too. It gets good at what you train it on. But if you feed it only fluffy cats, it's going to get confused when it sees a chihuahua in a sweater. Same with chest X-rays. If you train your AI only on perfectly centered textbook images from one hospital, it might completely fail when it sees an image from a different scanner. or one where the patient was leaning, coughing, or had some creative anatomy. And get this, it even learns the wrong things sometimes. If every pneumonia image in your training data has a portable label or an AP projection, it might start associating those things with disease instead of the actual findings in the lungs. Like a student who memorized the cheat sheet but never understood the test. That's why data quality, diversity, and good labeling are everything. If the labels are bad, the model will be worse. If the data is too uniform, the model will break in the real world. If the dataset forgot to include kids, women, or non-white patients, the AI will literally not see them correctly. Yikes. So yeah, training AI is kind of like raising a really smart but really literal toddler. It can learn fast and it can be super helpful, but it will absolutely draw mustaches on your textbook figures if you're not watching it closely. All right, let's tackle the question everyone's secretly thinking. Is AI better than humans at reading x-rays? And the answer is, it depends. Sometimes yes, sometimes no, and sometimes it's like comparing apples to oranges. If the oranges were glitchy and the apples had been up all night on call with 3 energy drinks and a broken mouse. Let me explain. When AI is trained really well on huge, diverse data sets, and it's been fine-tuned and validated, it can absolutely match or exceed human-level performance on very specific, narrow tasks. For example, detecting a pneumothorax on a chest x-ray. A well-trained AI can spot it with an insane speed. We're talking under a second. And in some studies, AI has flagged findings that human radiologists initially missed, especially in high-volume or after-hour environments. That sounds awesome, right? But here's the catch. AI only works within the box it was trained in. It can recognize patterns it's seen before, but if something weird shows up, something rare, unusual, or just different from its training set, it has no clue. It doesn't pause, it doesn't say, "That's weird, let me phone a friend." It just guesses, and that's dangerous. Because one of the greatest skills humans bring to the table, especially in medicine, is the ability to know when we don't know. To say, "This looks off, but I can't quite put my finger on it. Let's get a second read," or "This doesn't fit the story. Let's call the floor and talk to the nurse." AI doesn't do that. It doesn't have clinical intuition. It doesn't know when the patient is wheezing, or that they fell 2 weeks ago and now have that weird hip pain, or that person doing the exam thought the tube looked off and shot it anyway. It doesn't know context. It doesn't know how to break the rules when it needs to. And it sure as heck doesn't know that your PACS is glitchy today and that the exposure numbers are all out of whack. So yeah, AI can be better than humans at specific tasks, like spotting common conditions or highlighting urgent findings, but it doesn't replace the human layer of judgment, experience, or gut instinct. Instead, think of AI like a super fast, very literal assistant. It's the tech student who's great at the bookwork, but you wouldn't want them setting up a trauma series alone at 3 a.m. The best results happen when humans and AI work together. You, smart, experienced, educated, you use AI to get a second set of eyes, catch things faster, maybe save time. And the AI gets you expertise to steer it right, avoid misreads, and handle the weird edge cases that only a real human tech with real human life experience would notice. Let's zoom out of theory land and talk real life. Because while AI might sound like something out of a sci-fi movie, hospitals are already using it right now, in some pretty impressive and sometimes surprising ways. In emergency medicine, time is brain. Every minute that passes during a stroke can mean lost neurons. Some hospitals now use AI algorithms that automatically analyze head CT scans the moment they hit PACS. The AI looks for signs of an ischemic stroke or a hemorrhage and instantly alerts the stroke team. And get this, it often catches it before a radiologist has even opened the study. That's not just cool, that's life-saving. Now, is it perfect? No. But in a fast-paced ER setting where docs are juggling 47 things and someone just dropped a bedpan in hallway 4, Having AI flag, hey, this one's urgent, can shave off minutes, and minutes matter. During the height of the pandemic, hospitals were drowning in cases. AI tools were deployed to analyze chest x-rays and identify COVID-related lung patterns early, even in patients who weren't yet showing classic symptoms. It helped providers triage cases faster, prioritize isolation, and conserve precious resources. Think about it. AI helped doctors decide who needed oxygen, who could wait, and who needed to be monitored like a hawk. Was it a magic fix? No. But it was like having an extra tech on shift who never takes a lunch break and doesn't mind reviewing 3,000 chest x-rays in a row. Radiologists and techs often deal with massive imaging queues. Some of these cases are routine, but some are ticking time bombs, like a tension pneumothorax or an aortic dissection. AI now helps triage systems reorder work lists based on urgency. If the AI sees something potentially life-threatening, it bumps that study up to the top of the list. Imagine you're buried under 60 unread chest x-rays, and one of them is a massive pleural effusion collapsing a lung. Instead of that case sitting in queue until it's next, AI says, hey, maybe look at this one now. And you do, and you save a life. But here's the thing, and I can't stress this enough. AI is a tool, not a crystal ball. It's not infallible. It's not a replacement for your training, your eyes, or your instincts. It doesn't know that your patient was coughing during the exposure, or that the image was taken post-surgery, or that you just know when something looks off. What it can do is make you faster, help you catch what you might have missed, and maybe give you just a little more peace of mind in that chaotic environment. So no, AI is not coming for your badge, but it might just become your new favorite coworker. You know, the quiet one who works fast, doesn't take breaks, and never eats your lunch out of your break room fridge. All right, before we wrap up, let me give you a little teaser for what's coming in episode 3, and trust me, you don't want to miss it. We're going to do something that sounds super intimidating, but I promise it's not. We're going to build our own basic AI model using a free tool called Nime. And here's the kicker. There's no coding required, like none. If you can drag and drop a file into a folder, you can build a machine learning model in Nime. Nime is kind of like if Excel and Lego Mindstorms had a nerdy little baby. It's a visual programming tool that lets you build data workflows using blocks called nodes. Each node does something, like load data, clean it up, split it into training or testing sets, or run a model. You literally just drag the nodes onto the screen, connect them like a flowchart, and boom, you're building AI like a data scientist. Yes, it's as fun as it sounds. Yes, it's free. And yes, I'll walk you through it step by step. No math degree or sleepless caffeine-fueled hackathons required. We'll take a real public dataset, walk through the entire workflow, and by the end, you'll have built your own diagnostic AI tool. And even if you never want to be a programmer, you'll still come away understanding how these models work under the hood, which is a superpower in today's world. Because the truth is, AI isn't some mysterious black box anymore. It's something you can explore, tinker with, and use to level up your skills, whether you're a tech, a student, or a teacher, or just a healthcare nerd who likes to click buttons and see what happens. Okay, so before we end this party, we've got to talk about something important, like make or break the future of medicine important. Yep, we're talking ethics. Because AI isn't just about cool tech and faster scans. It's also about who's being seen, who's being missed, and what kind of assumptions are baked into the system from the start. Let's start with bias. AI models learn from data. So if that data is skewed, guess what? The AI will be skewed too. Garbage in, garbage out. Only it's in Latin and sounds fancier when we're talking about neural networks. Imagine your training data set is made up of 90% white male patients, mostly from one hospital system using one type of machine in one region of the country. What happens when that model is used in a diverse real-world setting with people of different ethnicities, genders, ages, and body types? Yep, the model might tank. It might misread images. It might completely miss findings in populations it wasn't trained on. And if that sounds like a recipe for health disparities, it is. Now imagine this kind of bias happening quietly, behind the scenes, inside an algorithm, that no one's double checking. That's how systemic bias gets automated, and that's terrifying. Then there's data privacy. Healthcare is one of the most tightly regulated industries when it comes to personal data, and for good reason. We're dealing with sensitive information here. Your body, your diagnosis, your digital footprints across multiple systems. When we build or use AI, we have to make sure the data is properly de-identified and handled under strict privacy frameworks like HIPAA or GDPR, depending on where you are in the world. This isn't just a suggestion, it's the law. And what about consent? Was the patient told their image might be used to train an AI? Were they given the option to opt out? Do they even know their X-ray could one day be part of a machine's learning experience? If the answer is no, Houston, we've got an ethical dilemma. Let's not forget transparency. Some AI systems are total black boxes. They give you a result, but no rationale. And that's a problem, especially in healthcare, where we're legally and morally responsible for our decisions. If your radiologist says there's a mass and your AI says there's no mass, who do you believe? And more importantly, why? We need explainable AI systems that show their work like a high school math student. Because trust in AI only works when we know how it got its answer. So yeah, AI in healthcare is cool. It's game-changing, but it's also deeply human at its core. It reflects our systems, our choices, and our blind spots. That's why people like you, techs, students, educators, healthcare pros, need to be a part of these conversations. You bring the context, the heart, the experience, and let's be real. You also bring the good memes to the group chat, so I trust you to handle this. Bottom line, don't just trust AI. Question it, understand it, keep it accountable. That's how we make sure the future of radiology works for everyone, not just the people who train the algorithm in the first place. Think of AI like a new grad tech, super sharp, tons of potential, but still needs someone with experience to say, okay, but let's double check the lateral chest. It can assist, it can accelerate, it can even impress, but it can't replace the full picture that a trained, thinking, feeling human being brings to the table. Because radiology isn't just about pattern recognition, it's about context, it's about storytelling, history, symptoms, instincts, and sometimes just that little feeling in your gut that says something's off. AI doesn't have that. And while it's getting smarter every day, it's still one piece of a much bigger, beautifully human puzzle. Now, in our next episode, we're heading back to a fan favorite, chest x-rays, and taking a look at the projections we didn't cover in full detail last time. We'll check out how AI analyzes those images, where it gets tripped up, and how to spot differences between helpful assistant and an overconfident algorithm. Looking at you, AI that labeled an EKG lead as a pulmonary embolism. It's going to be a hands-on, visual, and hopefully a little hilarious. In the meantime, I've got a question for you. What do you think about AI in radiology? Does it excite you? Freak you out a little? Make you want to build a lead-lined bunker and communicate only with Morse code from now on? Let me know in the comments. For real, I want to hear your thoughts. No judgment. This is a space where we learn together, ask questions, and sometimes laugh at x-rays that accidentally look like modern art. And if you liked this episode, go ahead and like, subscribe, and share it with someone you know who's curious about the future of radiology, or just really likes AI jokes. Thanks for watching Analyze with Casey. I'll see you in the next one.